Thank you so much, Bea, and to our other panelists for joining us, and thank you to everybody in the room. But also, we are going to be recording this session, so I'm sure lots of others, so everybody watching online as well, because there are people joined us virtually as well. It's my absolute pleasure to be chairing this panel today. Bea, apologies that we've started a little bit late. We're a bit like a doctor's surgery. We've got behind, so now everything else is behind, but thank you for being with us.
No worries.
So this panel is energy and AI. And I've got a brilliant panel of experts to talk through this issue, which is certainly not, not as developed as maybe some of the other conversations that we've had today. But what we wanted to look about at this is we're talking about enablers and solutions to how do we get this right. So there's been a year of a number of reports have been out, studies and headlines around the issue related to computer power and in relation to AI. But what we wanted to do today was kind of look beyond the headlines, past the headlines, behind what those kind of headlines that we see, and look at some of the real emerging ways that the use of AI can have in helping efficiency in the energy system, but also some of the ways, solutions and enablers to how do we get the continued or increased use of AI right from an energy point of view. So we've got some industry leaders, some experts here to share their knowledge, to share their thoughts and views on what solutions exist today and how they could address some of the concerns related to compute and AI and energy use. But we're going to be thinking, a bit broader around this topic as well in terms of what could AI technologies do to help address some of the energy challenges we have overall as well. So looking at it very much as enablers and solutions. So I'm going to kick off. We have a brilliant panel with us. I'm going to ask them to introduce themselves and perhaps do it in a who you are and where you come from, but also answer my first question, if I may. Multitasking, I think we can all multitask today. So introduce yourself and your organisation and where you come from on the question of energy use and AI from your perspective and from your organisation, because we've got a number of different perspectives here as well. So maybe, why it's important that we're talking about this subject here today at the Digital Ethics Summit. So maybe, Bea, can I start with you? I've obviously said who you are, but introduce yourself and your organisation and where you're coming from, on where your starting point is here on this energy use and AI conversation.
Sure, thanks very much. So apologies for not being able to be in the room there with you. Between the foot of snow I can see outside my window now in Munich and the train strike I believe you're enjoying, it seems like the odds were stacked against me being there in person, but great to see you all virtually. I am Bea Longworth. I lead NVIDIA's government affairs team in EMEA. NVIDIA's a tech company. We're best known for creating kind of semiconductor graphics processing units, which are very efficient at a range of different compute problems, but the one that's probably most relevant to our discussion today is artificial intelligence. And for the purposes of today's conversation, it's important to note that GPUs are part of a family of semiconductors broadly known as accelerators, like FPGAs and ASICs. This kind of processor sits alongside the CPU to offload specific compute jobs, get them done faster, and it makes the whole system more performant and, crucially for our topic today, more efficient. Let me take a step back to answer Sue's question on where NVIDIA is coming from on this topic, and maybe start with the basics. Climate change is an existential threat, and we need all the help that we can get if we're going to do something about it. And AI really has the power to accelerate not only climate science, but also to address some of our current energy challenges. And we need to take full advantage of this technology if we're going to achieve our climate goals. And I think it's important to acknowledge that AI is a worthwhile use of energy. It's not just about, asking ChatGPT to write you a Christmas carol about a train strike in the style of Taylor Swift and Slade, although please do that and then send your carols to Sue. That would be amazing. We also need to... I'm here for you, Sue. But we do need to acknowledge that the AI is a compute workload. It consumes energy in the data center. And as the demand for AI increases, of course, that's pushing up data center energy consumption and potentially increasing associated greenhouse gas emissions. So the real question here is, how do we ensure that we're meeting our climate goals, that they're served and accelerated by AI rather than undermined by our use of artificial intelligence, and allowing AI data center energy consumption to continue to grow at its current rate is not an option. It's 2% now. If we don't get on this, it could be 8% by 2030. We need to flatten this curve and then start walking our way back towards a truly carbon neutral AI industry. It's a complicated topic. I'm sure some of the other speakers are going to introduce different aspects of this, like using renewables, AI models that require less energy to train. The way I think about this for the purposes of today's conversation is what can we do now? What technologies already exist to help us cap data center energy consumption by maximizing data center energy efficiency? And that brings me back to the topic of accelerators, which I mentioned early on in the conversation. Managing how much energy a data center consumes, understanding that metric is not just about total energy consumption. It's about how do you achieve the maximum useful amount of work per watt of energy consumed, so performance per watt. Think of it maybe in terms of moving house. If you have a really massive van, you can get all your stuff in it and you just need to make one trip. If you've got several small cars, then you need to make lots of trips. And although the big lorry consumes more energy, overall, if your smaller vehicles that consume less energy make more trips, your overall power envelope is bigger. So it's all about that power per watt metric. And using accelerators which make workloads like AI more efficient is an immediate route we can get to that goal of increasing the benefits of AI within our available energy budget by making data centers more efficient. I can talk a bit more about sort of some examples of this later on, but Sue, maybe it'd be good to hand over and go to our next speaker.
Yeah, thank you, Bea, and thanks for giving us that focus as well on where are we right now? What are the solutions? What are the enablers? It's really wanted to talk about. And look, this is perhaps the start of a conversation that we'll need to continue, right? We won't cover everything in this session today, but going to the room now, and perhaps let's start down the line. I've got two Davids here as well. So we're going to go David number one. David Bloom, can you introduce yourself? Sure. What's your kind of starting position and thoughts on this, given KO data and where you're coming from? And why do you think it's important that we're talking about this today? I would love your perspective.
No problem. I'm David Bloom, and I'm chairman of KO Data, and I am general investment lead over a number of data center projects globally. My take on this is almost an extension of what Bea was saying in terms of, so KO Data has already for a number of years been striving for a better power efficiency. So for example, we have one of the leading PUEs in the country. We actually are the host of the Cambridge One, which is the NVIDIA supercomputer. And we're DGX ready as well. But all these things sound like buzzwords, but actually really important in terms of, to that point of, it's not just about what we're doing, but how we're doing it. So it's inevitable that we will require more compute, more data center space, but the question is how are we delivering that all the way through the supply chain, from the construction materials that we're using to the construction methodologies that we're using. I mean, so for example, my focus is actually, back to that point of what can we do today, is actually on waste, right? So before we get, I suppose, more efficient, more green, whatever it may be, which are objectives as well, and we've taken quite large steps towards that, is I think as an industry and as a country and as an economy, we waste a lot of power. But David number two will probably touch on that. Well, I think probably David squared, because I think two sounds bad. But the point is that we have inefficiencies within the grid. We have inefficiencies in our build methodologies. So for example, we've started to employ in the past few years digital twin technology. Now you could say, well, what's that got to do with anything? Well, firstly, it is driven by machine learning, and what it does is it starts to eliminate mistakes. Yeah, so things that we have to redo, because when you have to, funnily enough, when you have to redo something physical, like pouring of concrete, for example, not that I'm talking from any experience whatsoever, you have to kind of undo that. And so if you refine your methodology in a more virtualized environment, it allows you to actually make less mistakes, less what they call change requests, because we like to talk positively, and therefore have efficiency. I think it goes even further than that in terms of, and then you can spend your time working on what are the materials that I'm using. So for example, I know so you always like us to bring examples. So there's companies now that as it happens that we've had small involvements with that have more eco-friendly concrete, for example, and then on top of that is 3D printing of concrete foundations, where you're using 30 or 40% less, but achieving the same load. So I know this at the moment doesn't sound like we're talking about servers and compute and AI, but we are, because what it's doing is it's all of that. It's almost a virtual circle. That the AI learning models that are existing in data centers are allowing us to develop and move forward every part of the delivery chain, that is from inception to delivery, and get more efficient, as B says, in terms of how are we deploying power, how are we cooling buildings, how are we getting the most out of our rack space. But again, I'll stop there. But that's kind of my angle on it.
Yeah, well, it's important to remember the bigger ecosystem or the bigger delivery chain, as you say, and how it's looking at all the enablers and all the solutions of how we get this right, which is the point. So thank you, David number one. We'll have to stop calling them David number one and David number two. David Squared, as David said, please introduce yourself. And I know where you're from, so I'm really great that you're here as well. But also, from your organisation, Octopus Energy, where do you stand in this kind of conversation, or what would be your starting point?
Sure, thank you. Thank you for having me. David one, or I'm not sure I'm square, maybe square root. So I'm David Sykes. I lead the data team at Octopus Energy. I think if you've been on the tube or listened to any radio stations recently, you're probably well aware of who Octopus Energy are as an energy retailer. We're now, I think, the biggest energy retailer in the UK, 6 million customers. What you may not know about us is we also have a technology business. So we license our digital platform that allows us to run a modern retailer called Kraken. We license that out to, so if you're a customer of EDF or E.ON in the UK, you'll be using our platform. We also have a generation business, so we build wind turbines and solar stuff at grid scale. And we have a flexibility business which manages both grid scale batteries, so huge grid scale batteries, all the way down to fleets of electric vehicles. So
you're doing a bit of both, really, on this energy use as well as using technology to help energy use, right?
Exactly. And I guess like what knits all that together is applying technology to enable net zero, both at a household level, because net zero is fundamentally a household change, but also at a system level, because you need the whole system to work. On the AI topic, I think we come at it from two angles. We are both a user of AI, so we don't build our own chips, we don't run our own data centers. Those are very, very difficult things to do, but we do build a lot of technology and utilize AI algorithms across our business. But we also have a unique view of the energy system, not just in the UK, but globally, and how that's coming together. And I think I actually had to do a bit of research on like how AI is not something I think about data centers too much, thankfully, because people at AWS abstract a lot of that complexity away, and people like David abstract that complexity away for us. So I had to do a little bit of research on this question. What I found out was that it's about 2 or 2.5% of UK energy consumption is data center consumption, which is a lot. AI is extraordinarily useful, so I don't think we should be beating ourselves up about that, and generally sort of compute is extraordinarily useful for society. I actually think the challenge here is that is only, even if we get to 8% of UK demand being compute, that's only a problem if that energy is not being generated in a clean, sustainable manner. And so another statistic I like is that in 2022, we curtailed, so we basically paid renewable generators, wind generators, to curtail 6% of their generation, and of that, and wind generation is about 25% of UK generation. So we're actually turning off wind, typically in Scotland because it sits north of a big transmission constraint. And then we're using a lot of energy in places like London because that's where a lot of the data centers live. We've also heard stories about data centers in West London unable to get planning permission because they're getting there's local network constraints. So I guess the question I have is like to reframe it, not just about how do we improve the efficiency of AI systems, but how do we like marry together all this abundant renewable energy, which tends to be in sort of network constrained areas, and all of this great super societally useful energy consumption in one place, so that we actually have a sort of symbiotic system.
Yeah, I think this conversation already is kind of reflecting on why when we developed this panel, we said we need to look beyond the headlines, because it's not a simple answer here, right? There's lots of different facets and lots of different parts of this conversation that we need to explore. But Tarja, lovely to have you with us as well. Give us your perspective from Faculty AI and where you sit, because very much you're like how we use AI to help people in their energy efficiency in the system, right?
100%. Thanks for having me here. It's a pleasure. So yeah, Tarja Stralman. I'm a director of business development at Faculty. We are an applied AI firm, one of the largest, if not the largest, in Europe. About 10 years old, 300 people, and very much a sort of a hybrid team of commercial folk like myself and the technical team, so sort of PhD level data scientists, machine learning engineers tackling real problems in society. So we exist across 4 business units. Energy transition has been the one where where's my home? A lot of work with the government, healthcare, life sciences, and retail. So across the board, private and public sector. And like I said, we're an applied AI company, so we build, deploy, and design bespoke solutions for clients. IP sits with the client, so we're not. So we built those for the client across these sectors. My background is energy, so I have a bias in that I think that is the core to solving climate change. So I think we're on the same page.
Well,
here.
you're on the right panel. Then,
well, no, indeed. So I get quite worked up. But I was in Shell for 13 years. The last 5 years of that in digital solution services, and heading up one of our corporate ventures we incubated together with IBM for decarbonizing the mining sector. So things beyond the hydrocarbon that it takes to decarbonize various sectors. So obviously coming at it from a very different perspective now with tech and AI. So I think putting things into context and going beyond the headline. What I've observed in various conversations around this topic of AI and energy, or not AI and the environment, first of all, I don't think it's specific to AI, it's technology, digitalization. It all kind of bleeds into one, but AI is the hype right now. So ultimately, compute, really. But beyond that, to your point, it's not just energy use, it's all the other environmental ESG metrics that you need to be thinking about. And keeping in mind also that AI has profound positive impacts that we're already seeing across society. So I think it's sort of justified, but we need to be mindful of the fact that energy use is growing, everything else. And I think where AI is standing out is that the takes faster than and the hurdle for this technology, not just by organizations, but are practically zero. And to Bee's point, it sort of comes back to, well, are you using this technology for good, or are you making your selfies look good? But through generative AI, which is the hungriest of them all, energy hungriest of them all. And putting it into context, there's 120 zettabytes of data being created and consumed in 2023, 60 times higher than 2020. I think, again, as an applied AI company and as a person with kind of energy at heart, I think it comes back to, are you using the technology responsibly? And in the energy context, there's a ton of stuff that you can do with AI. So kind of building on your thought process. So what we do is really looking at how can you apply AI to reimagine processes, decision-making, operational performance across sectors, and in energy specifically, how you help the energy system transition to a greener state. I.e., incorporate at scale renewable generation, which means there's more fluctuation in terms of your, the generation that the grid is having to absorb, as well as completely new demand patterns when suddenly your consumers become also providers of energy. Your EV can be you consume energy, but you can also send it back to the grid. So the whole system is much more complex than it was before. We can't build a completely new infrastructure of a second grid, which is technically what we need. So ultimately it becomes a data problem, right? Of how do you balance demand and supply across the grid and the distribution, transmission networks without having the option of building completely new infrastructure. And that becomes, that comes with understanding of, forecast of demand, maintaining your voltage, safe levels, forecasting your generation patterns, all of that. So it's a data question, right? And a lot of the work that we've done has been with the grids and the networks around just, grid stability and reliability, first of all, but then also giving more closer to real time, more accurate probabilistic forecasts of what's likely to, what that demand generation balance is likely to be. There's a lot in the asset performance. Assets, any industrial asset, really, a lot of old-fashioned, maintenance, but also things like, maybe we'll get into later, and complete with resource allocation, how you deal with customer-facing operations. So across the board, it comes back to the end of the day.
So just to follow up the point of it's a data issue, and I was thinking, David, from Octopus, obviously you mentioned Kraken. Is that how you're using Kraken to kind of make sure that the bit of the energy system that you're running, is it data and AI that you're using to kind of get the most efficiency out of it? Tell us a little bit more about how Kraken works, I suppose.
Yes, there's sort of two lenses to Kraken. There's the retail arm, which is effectively a full stack solution that lets a company, a utility like E.ON or EDF or Octopus, or in Australia we have Origin, we're just about to launch with Tokyo Gas in Tokyo. It basically lets them run their business in a modern way. And really the heart of that in terms of system change is allowing them to launch modern products, which means like launching an EV tariff that has smart dynamic time of use pricing that reflects the grid, or launching an EV product where you just put your your preferences in, and we do the optimization behind the scenes, and that's where the flexibility engine of Kraken comes in. So what we do there is we basically take all the preferences across a fleet of EVs, optimize them, and then send that dispatch out against typically a pricing signal. So we're optimizing against a pricing signal which is in the UK and in most regions. Renewables master brain that does everything. I think quite a lot, and I think quite a lot of networks get themselves tied up in that thing. We're thinking like, oh, we have this. Want to have to you.
They said the magic word. I should chuck you out.
There you go. Or sort of benevolence going out. And actually, the system is far too modular and far too complicated. So the way we think about it is create the right price signals and interfaces. So by interfaces, I mean markets, so financial interfaces, but also data sharing interfaces. So that might be, how does an EV know what the right time to charge is? It's probably going to take that direction from a market signal, or it might also take that direction from some combination of a market signal plus a network hold signal, where the network's saying, actually, I'm overriding the market signal. And then it's any complex system needs to be multiple entities operating. You know, the internet doesn't run. The internet is one of the most complex systems we have, but the internet doesn't run with like one central optimizer saying you get this number of packets, you get this number of packets. It's sort of constantly rerouting and re-optimizing itself. So that's the way we think about it. We're trying to build the really starting from the customer and working back up through the system, like building the tools and systems that allow us to operate in that way.
That's a great way of thinking about it in terms of that those processes obviously automated and could be AI driven. So AI helping. It's right, getting them right. David just mentioned, I always like kind of best practices and examples, so well done, David, for raising. And we're talking about solutions now. I was just thinking actually to David and to be from an industry and maybe from a more of an infrastructure point of view. David, to your point around the delivery chain, the system, thinking about it from a data center infrastructure and compute power, you know, people that need compute power and you guys providing the infrastructure is enough, or of how we're getting that right, or have we moved that on to thinking about is there more need to do to bring the community together and maybe more in that partnership? And B, maybe same question to you in terms of examples that are helping us to, you know, support and get this energy consumption right for compute, you know, not just AI, but compute right going forward. That makes sense. Sorry, it's been a long day. Did that make sense at all?
Yeah, I'm going to go with yes. But ladies first. I'll let.
B, did that make sense to you? Can you give us any examples?
Yeah, I think it did. I apologise in advance. Ironically, my connection has started deciding to be a bit shaky, so hopefully this is going to come through okay. If it doesn't, I'll switch off the video and see if that helps. But I think it's really important to remember that we should all take heart from the fact that it's not just, let's say, a moral imperative that we need to ensure that our application and use of AI is in line with our climate goals. It's also a commercial imperative. Maybe that's a cynical thing to say, but it kind of gives me hope that there's a stronger path to actually achieving our objectives, because there's a very obvious commercial imperative. If you save energy, you save carbon, but you also save money. So there's kind of harmonization, if you like, between climate goals and balance sheets. And data centers have to live within the power budget of the world's energy grid. And therefore, you know, energy is becoming one of the major gating factors to our ability to deploy AI to benefit not only climate science, but also our economy and our society. So it's really imperative that we do get this right. And I think it's probably true that market drivers are likely to deliver the required result more quickly than regulatory measures because of those factors. Companies want to benefit from AI. Companies want to do it in a commercially viable, affordable way, and therefore doing it in a way that's very power efficient just makes complete sense. So and this can be a topic where it's easy to get bogged down in the the existential crisis that we're facing. So to me, that's a bit of a glimmer of hope, if you like, that alignment between commercial objectives and imperatives as well as climate goals will probably actually be a very positive driver here.
Thank you, B. David?
So actually, Sue, I've got a live example for you.
Oh.
He says, as if I've been lined up to do so.
Don't tell everybody.
Don't tell everybody. We'll find out. Actually, I actually have two examples. So today, actually, we announced a collaboration with JISC, and so for me, one of the best examples in the sector at the moment is what happens in research and educational institutions and so on, because they are much more open to it's actually just the compute power used to model out certain things, to do research projects, etc. So JISC, actually, for those of you that aren't instantly familiar, is what brings together all of the research universities in terms of how do they procure compute, essentially. So it's a really good example of where we can help all of those organizations to access high density compute power without individually having to invest in it, which by the way, back to the B's point about being commercial and also the imperatives. So they're not spending that money, which a lot of them don't have, and they're also sharing a bit of resource which is there for maximizing that. And we had another actually NVIDIA example is that during the pandemic, the Cambridge One was multiplied by a variety of different parties that were all using that compute to do quite critical bits of research, which impacted the vaccine and various other modelling that happened during that period.
Thank you very much for that.
Absolutely. So, look, I mean, it does get more difficult as you go, I would say, into the into the more rigid commercial spaces. But I think it's entirely possible. And the bottom line is, in that situation, everybody doesn't need their own supercomputer. We can share and book time like you would, I suppose, in a I was going to say a swimming pool, and I don't know why. But it's a not bad example in terms of we all use public facilities, and there are ways of doing your own thing within that space. So obviously the collaboration around innovation. So how do we were just talking about this just before the panel, but how do we take things like data centers make a lot of heat, for example, and we have got to get better in this country about using that heat for something. So district heating is a really good example of I wouldn't say it's simple, but it's reasonably straightforward. And if we can put in the infrastructure, especially into new builds, we will be able to reuse what is otherwise a waste product to something in a very effective way. But that needs a collaboration between different parts of the value chain, the house builders, commercial real estate people, data centers, local authorities, all thinking about, well, hang on a minute, how do we do this together? Which, as you know, has its challenges, but it's got to be possible because it's clearly the most efficient way.
The energy from a data center, I think it was in Wales. But
that's absolutely correct. And there's also the article where our dear friend Rishi Sunak wanted more power to his house for his swimming pool. So there are examples of where power comes into contact with water, but I think there's probably health and safety.
Yes, run a bath and then put any power
in your bath.
Yes, please.
It's not going to work.
I think we're covered for that. Oh, David, did you want to come in?
I just want to pick up on something B said about market drivers. I fundamentally agree with that. That like if you have a good commercial driver, there's amazing companies that will go and compete until
they create new markets, right?
Exactly, but right now we have when we think about the power price particularly. We can only operate in the context that we're in. And right now we have one UK power price. And so when there's loads of available power in Scotland and there's none in London, basically National Grid do what they have to do, and then they socialise the cost of doing that. So what that means is they pay wind generators to turn down, they pay gas generators to turn up, and then they say, everybody, you pay a fixed fee for that, or like a variable fee for that. And until we can represent to people building data centres that the energy should be cheaper in Scotland at these times of day because there's loads of wind and no demand, we're not going to get people moving data centres to where there is like abundant. The other thing is you can only operate within the infrastructure spine that's already here for us. So I think the cables to do it, and also local networks would say you can't connect that here because we haven't got the infrastructure. So thinking the government both short term from an operational perspective and long term from an investment perspective.
Yeah, that was one of the, and we are running out of time. It's amazing how support the development of more innovative solutions, more solutions and approaches perhaps that we need to look at to help with of energy and AI, and what could government do, or is there a role for government to do here? So Tara, maybe coming to you, and then I'd love to hear from the other panelists, and then we may have to wrap up. But Tara, I'd love to get your views on promising innovation solutions or promising, opportunities here, and how do we support the greater use of them? I suppose from your point of view, greater use of AI solutions to help people that are trying to do the right thing here, trying to get this right. And is there a role for government in supporting that?
Yeah, I mean, I guess what we haven't touched on is, in terms of regulation, is transparency of the emissions or the energy usage and how you report on it, and the targets and everything else. I think it is a little bit opaque still. Like you said, you have the cloud provider is kind of taking that complexity out of you. So how can you influence that as a consumer or as a company? And how do you create that transparency? That's just sort of, I don't have an answer, but it is an observation, I think, that isn't necessarily talked about as much. And should we not have that as a part of, your responsible AI framework? We talked about fairness, bias, security, transparency, explainability. Well, should sustainability, or shouldn't it be one of those? So if you're building a model and could be using, to your point about the energy prices. But the real opportunities, I think, in this space that we're looking into are perhaps in sort of your hybrid assets that we're starting to see now, where you might have solar and battery, or even, there's floating solar, offshore wind, maybe an electrolyzer, and how you manage those hybrid assets, not only from a kind of asset, operational perspective, but in terms of your revenue stack and how you participate in the energy markets. There's a real value case here for the developers and the operators. But some of the signals that we're seeing, especially from the larger developers, is that they're so distracted by the contracts of difference and the disastrous auctions that happened this year, where no new offshore wind was allocated. There's supply chain inflation. There's all these sort of supply chain issues that it feels like the industry isn't even getting to address that point, because they're so distracted by fundamental things that are blocking them. But yeah, so I feel like if we were a bit smarter on the opportunities economically that you develop for the renewables industry, for instance, there's some really cool stuff that you could be doing. Similarly, on how you power data centers, they're ideal customers of kind of guaranteed 15-year offtakes and PPAs from renewable assets that then take the risk from the financiers and the developers, and we're perhaps not seeing that as much as we could.
David, innovative solutions that you think point to that excites you about maybe what's coming down the line, and also how do we support, is there a government role to support more innovation in this area from what you've
for me, working backwards, the government role, to me, I say is quite simple. Just focus in on infrastructure.
Yeah.
Getting that right for us. The innovation can happen on top of that, and there are already plenty of companies innovating in this space. But it's really about, a bit like David was saying, is how do you make it possible to actually use some of this power that's available in other places, etc., etc. I mean, but to the other point of things that I'm seeing, I think that there is and there has got to be a more granular approach within the data center market, and we're deploying within our sites, feeding back a lot more data to the end users about what it is their computer's doing, the power it's using. It's not using the whole principle of total cost of ownership, as opposed to just a single, well, what's the kilowatt price? Because it's not the only thing impacting it. And I would also therefore say, lastly, is that we have to get smarter that when it comes to data storage and access, that old data is equal, but some's more equal than others. And what I mean by that is everything from what I say the quality, and it's been touched upon before, of we keep everything, almost, right? So we need to start being a bit more ruthless with, but then also in terms of certain compute does not have to be in major conurbations. I mean, we and not per se in this country, in London. I mean, David points out London is the core market. We're actually starting a development in Manchester, and looking at other regional areas, because it's not, there is an economic point there, but it's also because we can start to see, well, actually, local workloads, it's much more efficient to have them locally. So it's joined up thinking, which is always challenging, but we have to promote it from within our individual industries, and the government should be facilitating that conversation to happen.
Great. David, any last words from your side? And then B, I'll give you the last word before we close. But innovations, and I mean, you raised it yourself, right?
Yeah, I'll keep it brief. So on the government question, I don't know who said this, but I like the phrase "government should do what only government can do." Which for me in this sector is infrastructure. It's throwing like low cost of capital funding at like early stage and research, and it's getting the right market framework in place. And then innovation wise, I think David might not like this, but I think like edge, like inference at the edge is going to be is very exciting. So a lot of inference workloads, I think, will move to edge computing, which might take a bit of the workload. I think data center workload is definitely going to grow, but it might take some of that off because a lot of it's being done at the edge. Yeah,
very interesting. Edge is another area of conversation we need to get to. B, final word for you, and then we're going to have to wrap up, I'm afraid.
Well, I'm going to be terribly dull and agree with the remarks of the previous speakers. I really agree that metrics are important here. This kind of stuff can come across as very dry and dull, but having an effective metric which is mandating the behaviours you want rather than mandating counterproductive behaviours is incredibly important. So I think that's somewhere that government regulators can be really thoughtful. I also agree with the person I'm going to refer to as David Prime, that government has an important role to play in terms of academic compute procurements, which tend to be largely government funded. They have an opportunity there to select 4 projects which have a sustainability aspect in mind, and more broadly in public procurements. I think that's a really valuable and powerful tool that government can use to drive this kind of behaviour and markets. And then I think finally it's just important to bear in mind that high energy consumption is not inherently bad, as long as what you're doing with that energy is worthwhile and you're doing it in an efficient way. And I think if we can bring together, as David said, all of the different stakeholders to this piece, there's a really exciting opportunity not only to hit the climate goals, but perhaps, Sue, as you mentioned, to even open up new markets. And David did mention swimming pools and didn't realise why he had, and I've worked it out. There is a company called Deep Green Technologies that uses data centres to power and heat swimming pools. So I think that's what you were getting at, David.
That's correct. Two points.
Well, look, thank you so much. Look, we've only scratched the surface of this conversation, and apologies that we've come to the end of our time. I think it shows to me that there's a lot to unpack here and a lot of different facets. And as we said, you've got to look beyond the headlines and look underneath these issues, and we'll need to continue to do that. So definitely a conversation that I think we'll need to continue at techUK. But right now, and I'm sure B, you'll agree, this panel has been anything but dry and dull. This has been wonderful. So thank you to our panel, to David Sykes, Head of Data at Octopus Energy, to David Bloom, Chairman of KO Data, to Tarja Strauman, thank you, Energy Transition Practice at Faculty AI, and to B Longworth, Government Affairs at NVIDIA, for joining us virtually. Good luck, B, with the snow, and can we thank everybody in the normal way? Thank you so much. Thank you, guys.